More seats left down here in the front. Place is filling in really nicely. Hopefully we have enough seats for everybody. That's a great way to kick off Connect. All right, still quite a few people coming in. All right, so while we're waiting for everybody to get finally seated, let's try an experiment. If everybody could just wave like this, right? All right, good exercise. We've had your morning exercise now. If you haven't made it to the fitness center, you're still okay. Okay, good morning. I'm Joe Bates, and on behalf of the Linaro management team, I'd like to welcome everybody to Hong Kong and Linaro Connect Asia 2015. We have a really exciting week planned. There's lots of good stuff going on. I think that everybody will be exhausted by the end of the week, as is usually the case, but even more so this week. I mean, there's just a tremendous amount of stuff, a lot of planning. Now that we have Connects twice a year, there's almost 6 months of planning by the team that go into this event. So it's packed with even more things than before. We get a lot of great feedback, and we try to improve it every time. So keep the feedback coming, it's great. So one of the major changes this time from a logistical standpoint is we no longer have an app. We're not using the app anymore. We're using a tool called Pathable. And Pathable is accessible over the web. And it's also mobile friendly. That was one of the reasons we liked it, is because you can use it from your desktop or your laptop, and it looks right, and it will also look right from your mobile phone too. So you can go to this website right here. It's also in the materials you've been given, and you get the information there. Another nice thing about Pathable is you can actually book a meeting with anyone. So there are so many of us here, and it's such a small world that most of us have connections to others that are not only just with our company that are attending here, but other people from other companies who we may have used to work with, or we've been on a committee with, or so on and so forth. So anyone can go into Pathable, and you could book a meeting with someone else. You can see their availability of busy or not busy, and put in a meeting request. And it defaults to meet at the registration desk. But there are also some rooms available too. So if you'd like to book a meeting and need a room, you can talk to the folks at the registration desk if one isn't available, or just find a corner somewhere. But it's a really nice tool for collaboration from that standpoint. And that's one of the really important aspects of Connect. In addition to all the information and technical talks and deep dives that we do, the collaboration piece is really important too. And that the Pathable tool just allows us to do that a lot better than we've done it in the past. So hopefully you enjoy that. We'll welcome everybody's feedback on Pathable this week. So all the meetings, we're on the first floor here right now. All the meetings are at the basement level. It's the one floor the elevator doesn't go to. There's escalators that go down there. You can get to it. And then the hacking rooms are all on this floor except for ARA. And while the hacking rooms are assigned to various working groups and segment groups and teams within Linaro, they're not exclusively assigned. So for example, the power management working group might be in one hacking room, and they will meet in there, and it is assigned to them. But there's plenty of room in that room. So anyone can really go into any of the hacking rooms and hack away, or maybe you just want to hack near one of the particular teams in Linaro. So they're open to everybody. We wanted to make sure everybody knew that. They're not exclusive. And we have a little bit of a slide malfunction here. There we go. Okay, so as usual, we're doing a member dinner. So it's going to take place on Wednesday night. We're going to Tsim Sha Tsui. We'll get to see the light show, the Hong Kong light show, and walk around Tsim Sha Tsui. If you've never been to Tsim Sha Tsui, it's really an exciting place. It's sort of like Manhattan in some ways, an Asian version of Manhattan. There's a lot going on there. A lot of activity. We'll have a great dinner. They have this massive light show. And if you're a member and you'd like to come, please see Christine at the front desk and put your name on the list. And we're going Wednesday night. So if you could let us know, that'd be great. And lunch every day is in Cafe Aficionado, which is on the ground floor. It's the same place that breakfast took place. So that's pretty straightforward. And there's also a photo competition to win a Phantom 2 drone. I don't know if you've seen the Phantom drone. It's perhaps the best commercial, most widely available commercial drone in the market. It's pretty cool. It's the one that there was a guy that actually flew it to the White House or onto the lawn of the White House a few weeks ago. It's a very capable little device. It's a pretty cool device. And so there's a photo competition. You can go to this website, the Connect website /hub to check out what the details are. It involves taking 4 different types of pictures while you're here. All the entries have to be in by Wednesday, and at the awards dinner on Thursday night, we'll pick the winner, and they will win one of these drones. Really cool device. So just a few highlights for today. we are actually going to do the group photo today, and with such a full room, it's going to be a perfect day for a group photo. And it's actually after the keynote. It's going to be right outside on this floor in the foyer out here. So after we're done, we're wrapping up, and George is done. If you could just go outside, and we'll take the official Connect group photo that lives on, and we'll just get it out of the way right now. We also changed the schedule a little bit. Usually after the keynote, you walk out of here and you start to go into your sessions. But for today, we've changed it to organize team kickoff meetings. So rather than having just general sessions, you'll have a specific kickoff meeting with your team in one of the meeting rooms here. You can check Unpathable to see where you're supposed to be as part of your team. And then tonight is sort of an open night for team dinners. So you can get together with your team or some people that you know, and if you don't know a place to go, the concierge here at the hotel is really quite good about helping you find a good place. We've been to some good places. We've been here for a few days, and they've really been extremely helpful. So the concierge desk is actually upstairs next to the lobby. Those guys are great. So I would encourage you to talk to them. So that's it for logistics-wise. Last time at Connect in Burlingame, we really had this tremendous keynote where we had all sorts of different demonstrations going on, and there was a lot of technical coordination involved to pull it all off, a lot of special effects. And if you thought that was fantastic, you ain't seen nothing yet what's going to go on today. So with that, I'm going to turn it over to our keynote speaker and our CEO, George Gray. George? Thanks, Jeff.
Okay, welcome everybody. Thank you very much for coming. Some of you have come a long way, some not so far, but we really appreciate it. And it's amazing to have a full room on first thing on a Monday morning. So I'm really excited about what we're going to talk about today. We've got a number of topics, so I suggest we just go straight into it. Year 5 doesn't seem like it. The last 5 years have gone in a blur, but we've achieved a huge amount, and in a lot of respects, we're only just beginning the journey. I think this year is going to be one of the most significant years for Linaro and for all of you and everybody in the ARM ecosystem, and we'll talk a little bit about that today. So our mission is to collaborate, develop, and deliver technology upstream, having proven it on member products. And this benefits Linaro members, first and foremost, but also the ARM ecosystem in general. It's very important to all of us that the ARM ecosystem works together and grows as an ecosystem. Together, we are far more powerful than any one company that's in this space. And together, we can actually make the market bigger for everybody. So the value of Linaro membership is that between ARM and the technology that ARM delivers, and Linaro as a place to collaborate, we all have the opportunity to lead open source on the ARM architecture. We can't do it individually. Together, we are very powerful. And that is what Linaro and ARM together can help all of you as the place to lead open source. We want ARM to be the best architecture, the leading architecture in open source. And the reason that's so important is that the value of ARM is in innovation and differentiation. The speed at which change is going on in our industry, ARM processors, ARM SoCs are coming in all sorts of flavors. You're going to see some of that today. In order for that to actually be a single ecosystem, we have to work together. We have to work together on common platforms and then enable each of our own differentiation. And we're going to talk about that today. Working with Linaro, Linaro has now built an incredible team of open source experts and maintainers and people who have a lot of knowledge about the ARM architecture and all of your products. And we also obviously have close links with the ARM team as well. So applying open source into your products is something that's very important to us. And we want to help you get to market faster with new technology. So if we look at ARM software, there's actually 3 platforms that are really important today. The first one we don't directly have much to do with, but over 1 billion devices have been shipped on this platform. We can't ignore that. We all know who this is, and this is the core of what Linaro is involved in as a platform, Linux, and through Linux and the operating systems that it is a part of, including Android. And the third one is actually Windows, right? So Windows 10 has been announced. It's going to include support for the ARM architecture. And this is about the ecosystem. We need to have all of these platforms working together. The wars are over, they're won, right? There are these 3 platforms. So now we need to make them work together. And everything we do, we need to make sure that we make it as easy as possible for customers and end users to use any of these platforms seamlessly. But Linux is truly everywhere. This is a slide from the Linux Foundation. 1.3 million Android phones running Linux are activated daily, every day. Air traffic control systems powered by Linux. 8 out of 10 financial trades on Linux. Linux is the operating system of choice for big data. And it's a big project. It's the biggest project ever. 17 million lines of code. There's even some comments in there. There's over 500,000 commits and over 5,500 man-years of effort in this project, and all of you have contributed. ARM's market segments, well, we're all familiar, and in fact, Linaro started with its focus in mobile when we started. But there's disruption going on in other market segments. The traditional proprietary vendors are giving way to ARM and open source and SoCs and differentiation and innovation. And that's happening across the ecosystem. And Linaro has segment groups focused on mobile, digital home, the networking equipment space, and of course, ARM servers. But there's also the Internet of Things. And the Internet of Things is just such a big topic that you can't really categorize it into any one segment. It's driven by the fact that by 2020, there will be 30 billion sensor-enabled devices connected to networks. And there'll be 212 billion devices that are available to that set of sensors. So the scale of this is almost unimaginable. And all of the work that we are doing today is leading towards a world where what we've seen so far is nothing. Big data and the amount of data coming out of these sensors and flowing across the networks and having to be managed both from the user interface end all the way up to the analysis end is a key part of the software that we're developing. So I thought I'd make some predictions this year. They're actually pretty easy predictions, and then look at them next year and see how I did. The first one is that ARM v8 as an architecture has now been around for, well, 3 or 4 years since the very first chip the very first design was done. But this year, it feels like that momentum is finally going to be unleashed. There's going to be huge numbers of deliveries of ARM v8 silicon across every market segment, from mobile to networking to server. And I think this is the year that the hard work that's been done by all of you is actually going to start turning into real products. And I think we're ready. There's still a huge amount to do, but we're ready to actually deliver ARM 64-bit chips into real products and have users use them. It's also a year where we move from enablement, i.e. building the basic building blocks and making sure they work on ARM, and we move to deployment of servers. And this is about developing the ARM server ecosystem. We have to work together to do this. It's not about basic stuff anymore. The basic stuff works. Server software works on ARM today. Virtualization works, etc. But we need to now get real-life workloads deployed, benchmarked, and we need to be able to show why ARM is differentiating itself, right? What is the value and the benefit, the business benefit of using ARM, and all of the differentiation that all of you are creating. And we need to do that in a way that we can actually show the benefit of ARM in the server space through differentiation and the innovation. A lot of you know about ODP, Open Data Plane. This is actually a very important initiative in the networking space that's also going to affect the server space. ODP effectively allows you to have an API that abstracts the accelerators, the hardware accelerators moving data packets behind an API so that different vendors can differentiate in different ways, build hardware accelerators, and have a single API across them. And this is cross-platform. It's not just ARM. It's going to work on anything. And so the adoption of ODP is very important to enable the success of ARM in this massive space. And that doesn't only affect networking equipment manufacturers, but also with NFV, affects server manufacturers. So we need a lot of effort on making ODP a success this year. And I'm going to talk later about a new initiative, which I announced a little bit at last Connect, called 96 boards. We're very excited about this initiative, and we think it's going to make a big impact. Going to look at it next year. Okay, so Linaro in 2015, year 5. What are the kind of major topics that we're working on in Linaro? Kernel and power management working groups have some big tasks, working on delivering ARM's technology upstream. And this is not possible without working together. Linaro working with ARM and with each one of you on your products. There's no point in delivering technology upstream if it doesn't work on your products. So we need your help. We need to work with you, and we need your technical teams to work with us, because it will help you. So that's the Energy Aware Scheduler. There are a lot of technical sessions on this week. IPA, which is an improved thermal framework. These are topics that are being led by ARM in the open source architecture, right? ARM is driving new requirements because of the range of differentiation and innovation we're seeing in chips, because of the new features in SoCs. We're introducing new functionality faster than any other architecture on the planet, and we need software to drive that functionality. And by the way, that software's also got to work on all legacy hardware as well. So a lot of effort on that, as well as finishing and continuing the work on UEFI, ACPI, and also making sure that legacy boot architectures work on ARM v8. The security working group last year introduced the first true open source, fully functional, trusted execution environment, OPTEE, which was derived from work that originally was started by ST and is now fully open source. You can go and get this code from GitHub, you can experiment on it. And this year is about actually getting that onto member products and providing an open source reference implementation of how to do security. Too much of security historically has been proprietary. And it's very important that in order to be truly secure, you have an open source reference, right? And so this software is licensed under BSD licensing terms, so you can take it and modify it, and you don't have to give back your changes, but you have a reference that everybody can see and use. And delivering applications based on that platform is something we want to focus on this year. And lastly, virtualization. There's a huge amount of work going on virtualization. This isn't basic enablement. Virtualization works on ARM. KVM works, Zen works, QEMU works, containers work, right? But moving that into actual product requires taking the next step, which is going from enablement, from basic enablement into actual product deployment. And that's when the corner cases come up, and that's when we have to actually start really productizing this effort. And the segment groups are really focusing on the particular markets that they're working in. So leg is really, as I said earlier, all about this year productizing workloads, measuring and making server workloads work really well on ARM processors and taking advantage of the innovation that's happening. We're going to talk a little bit about that in a moment. LNG is focused on ODP delivery and the networking ecosystem deployment for networking equipment for ARM. There are a number of legacy issues that have to be dealt with, and there's new technology in terms of ODP, as I said earlier. LHG is working on multiple platforms, both Linux platforms, and we expect to get more involved in Android TV as Google deploys that. And there's a lot of work going on in that whole space around enabling multiple SoC vendors to compete in that space. The TV set-top box digital media space has been dominated by a very small number of companies historically. ARM provides the opportunity to expand the market for everybody, reduce costs, and increase the speed of innovation. And LMG is going to be continuing to work on Android optimization and is increasingly also involved for some members who are interested in some of the Chrome technology. So the first demonstration we wanted to do today was something that we haven't shown at Connect before. We're very excited about. Since the last Connect, Cavium have introduced the ThunderX SoC, which is an amazing SoC that Andrea Gallo, who's the director of the Linaro Enterprise Group, is going to talk about, and Ed Neville, who heads up the OpenJDK effort in Linaro, is going to assist on his demonstration. Thank you, Joe. Okay.
We're very excited with the latest Cavium ThunderX. We got AMD Seattle, we got Applied Micro Gene in the past, now Cavium ThunderX. It's the latest ARM 64-bit server. And every chip is unique. Everyone is different. This is what we love from the pace of innovation from the ARM ecosystem. Since we started talking about ARM servers, everything has been about hyperscale computing. So everything has been about replacing a big, expensive, power-hungry, hot brownie core with a big number of small, cheap, efficient, cold ARM cores. So this is hyperscale. And the Cavium ThunderX is really implementing this to the full. It embeds 48 ARM 64-bit cores in a single chip. 48 ARM v8 64-bit up to 2.5 gigahertz. And thanks to the special interconnect, you can have two chips back-to-back on the same board. So this is a massive 96 cores. It's amazing. It has multiple memory controllers, which is key. It has SATA, Ethernet, PCI. So when we got access to the board 2 weeks ago, we were really excited. And we thought, will it be up to the expectations? Will there be bottlenecks in talking to the external world when 48 cores try to access the memory or the disk? So we decided to really put it up to the challenge. We decided to forget about Drystone. That's easy, that fits in the cache. That's not a real stress test. We decided to do something serious. So we decided to look at Java straight away. We got the chip, the board 2 weeks ago. Let's try Java on 48 cores. Well, Ed Neville is smiling. He's been having fun. How is it going, Ed?
I'm not having so much fun now. I'm a little bit nervous about this, so if you'll bear with me. So what we're demonstrating here, this is on a Cavium board in Cavium's lab in San Jose, is a benchmark called SpecJBB, Java Business Benchmark. And it's essentially modeling a transactional system as you might find in a large supermarket. So basically what it's doing is injecting transactions, and you can see the types of transactions it's injecting here: purchases, returns, those sort of things. And it basically increases the rate of injections until it gets a 1% failure rate within 10 milliseconds. So in other words, to the 99 percentile level. And then that rate of transaction injection is known as the maximum jobs, maximum Java operations. Okay, so it's running here, and you can see it's got as far as 29% at the moment. And in the top, you can see HTOP running, and you can see the loading on all 48 cores. At the moment, they're not very loaded because the benchmark is running at 29%. But once it gets up to 100% load, all of those cores would be all green. Now, one of the nice things about the ARM architecture is the memory model on the ARM architecture. What you have is you have a weak coherency model in conjunction with a non-unified memory. And what this essentially means is that you don't get the memory contention that you see on other architectures. So if we could perhaps just maybe look at the next slide. So here's one of the results. So here I did a test with 8 cores, 16, all the way up to 48 cores, and measuring the maximum Java operations with a different number of cores. And you can see it's almost a straight line. So the performance is increasing linearly with the number of cores, which is ideal. That's what we want to see. The performance is not being bottled by the memory system.
Thank you.
Yeah, thank you.
So just think about that for a moment. 48 64-bit cores on a single SoC, and the ability of that SoC to run a transactional real-life benchmark at a linear performance across each of those cores. You can't do that with other architectures. I'm really, really excited by what's going to happen here. And congratulations for Cavium to getting that chip out. And we're looking forward to seeing what we can do with it. If we've done that in 2 weeks, we're looking forward to seeing what we can do with it next. So at the last Connect, I talked about a few activities that were coming soon. So I thought it was only fair that I really ought to give you an update on each of them. And there were actually 3 of them. The first was talking about preparing and making ready a developer ARM v8 server cluster with the goal of helping the ecosystem get access to a large amount of v8 hardware remotely and be able to production test software. The second one was the update or the progress we were making on Project Ara. And Paul Eremenko, the head of the Project Ara group at Google ATAP, came and gave a keynote last time. And the third was the Linaro Community Board program that I promised was coming soon and was under construction. So we'll give you an update on each of those. So the first one is the developer ARM v8 server cluster. That's now up and running. It's located in Austin in Texas. It consists of an array of both applied micro X-Gene servers and also early access to AMD Seattle Overdrive development systems. It's running both bare metal and OpenStack instances, both Ubuntu and Fedora and Red Hat PEAP for the early access program. We're expecting to put more hardware into this farm this year. And the goal is not to create a commercial cloud service. The goal is that this is a development platform that you can book in time slots of a week. You can perform evaluations and get access to hardware that otherwise would logistically be very difficult for you to get access to. And you can compare the results on different vendors. So a couple of the use cases that have already been put onto this stack. First thing is that there's been a lot of work being done in both Linaro and also member companies on OpenStack validation. OpenStack needs a lot of servers to get it going or to show it off, and therefore we've been using this server farm for validating and testing and measuring OpenStack. We also let the Debian folks loose on the farm we gave them a number of the machines, and they actually performed native builds of the next Debian release, Debian 8 Jessie, And as a result, a direct result of enabling this performance and testing to be done, I'm really pleased that the 64-bit ARM architecture is now going to be officially supported starting in Debian 8, which is the Jessie release as a result. So congratulations to the Debian folks. So other companies have also been doing, both internally in Linaro, but also member companies, and actually outside member companies have also been doing things on this developer cluster. Ceph testing, which is the storage, mass storage, cold storage software, has been going on both Ubuntu and Fedora. One company has been doing Spark, which is getting that up and running on ARM and seeing how it scales, which is a big data analytics package, open source package, and they've brought that up on ARM. And internally in Linaro, we've used this farm extensively for virtualization development and testing. The Linaro builds and baselines team is also starting to use it for native builds. So we're eating our own dog food here. And that's helping us enormously as we actually start using ARM architecture for our own requirements. And this is going to happen, obviously, outside in the industry as well. So we're really excited to see this farm up and running. You can book time on it at the URL here. You can basically go onto the Linaro website. If you go into the leg area, you'll find where you can book time, and you can book a number of machines if you want to actually build a cluster. And you can ask for either a bare metal or an OpenStack instance. Okay. So next update, Project Ara. How many of you have seen a Project Ara phone in real life? Hands up. Yeah, not bad. Okay, well, you now all have. Here is an Ara phone. It is consists of display, camera, processor module, and so on and so forth. And this is called the endoskeleton, connects everything together. A couple of weeks ago, there was the second developer conference for module developers. And the concept behind Ara is very exciting. It's essentially, it's a bit like the application store. You should be able to create a piece of hardware and get it into users' hands quickly if it isn't necessarily a piece of hardware that has to be in every phone. And so you can differentiate, and the speed of innovation around this architecture and this platform could be truly staggering. It could give access to hardware guys to millions of devices and millions of users. And the project is going very well. So Linaro has been involved in some of the software for this, partnering with Google, and I'm really pleased that in the last few weeks, we've actually fully open sourced a lot of the software that we're working on this project. So firmware, Gray bus technology, which is protocol software in the kernel to deal with Unipro, which Greg Crower-Hartman's going to talk about in a keynote in a couple of days' time, and Android itself, where we're making changes to Android in order to support modularity. And there are development boards and phones that are now available for developers to use to start developing their own modules and their own technology. This week, you're going to be able to see that. There's going to be the whole team from Project Ara. So the firmware team, which is a small company in Boston called Leaf Labs, and a team from France and other places in the world are all working on firmware. And within Linaro, we have a team working on Gray bus and on the kernel and on Android. So that whole team is here today, this week, doing a hacking session for the whole week, a sprint, if you like, and I'm expecting some great results from that team. So that's where we are on Project Ara. Some members have said, why are we doing this? Well, one, Google are paying for it, so that helps. But more importantly, we think this is fundamentally important to the future of open source and ARM. We think it's going to have a profound impact on the future direction of software and products. And that's driven by some fundamental changes and requirements that Project Ara have that we haven't really seen before. So if you think about Project Ara, when you start up your phone, it can be one configuration. But on the fly, you can take out a camera. Now, from a hardware perspective, we can probably deal with hot plug. Might need a little bit of software, but we can probably deal with it, put it back in, or put a new camera in that's higher resolution. And you can start thinking about the software implications of this, right? You've got quite a lot to do. But it's not only the hardware, it's also actually the applications. Because if you've got a messaging application that you can text and you can take pictures and all the rest of it, and suddenly you take your camera away, what do? Do you kill the application? No, because actually I may still want to use it for a text message. So how do I start thinking about applications being modular and dynamic, as well as the actual kernel and the operating system handling it as well? And I think that that Project Ara is an exciting project from the phone point of view, because it does have this ability of truly enabling innovation and differentiation to happen on the phone. But I also think the technology that's being developed here will have an impact on a lot of other market segments. So I really think this is a worthwhile project for multiple reasons. I didn't want to, because it takes actually quite a long time at the moment. We're still very early stages of getting software up and running on this phone. I thought I'd actually just show you what's involved in it rather than actually do it in front of you. So can we cue the video? So we did this last night. This is a disassembled phone. And so what you'll see, that's actually me, is me assembling the phone, the display, and then the various other pieces like cameras, processor module, and then there's a USB charger here, and then there's a media bar here. If you break your display, you can just replace your display. And then there's a battery module, which I'm pretty sure on this one is now completely discharged. And so there's the processor AP going in, and the battery module. And then a few moments later, there are the 4-Tux Penguins that come up. And then finally, Android boots. And this one, the battery is now completely dead. But there it is. That was last night, despite the fact the date doesn't say so. So Project Ara, this week, we've got some goals to actually get further. And there's a lot of work going on to the next stage of the project, which is called the next spiral. We're really excited by the progress we're making. There's a lot of work going on here. Please feel free to go in and chat to the Ara folks, but also let them get on because they've got a lot to do. One other implication of Project Ara. Anybody who's worked in the mobile phone space or the embedded space knows that ARM is a little bit of a problem from a software perspective. Everybody has their own proprietary software. Now that's fine. If you think about, there are certain technologies, they're patent protected, you want to preserve your value, and so you go and create some proprietary software. But it would be really nice if they played well together, right? As opposed to every time you choose a different vendor, you have to completely redo everything. And if you think about in the PC space, and indeed in the mobile space, today, when you plug a PCI card into a PC, it just works. When you plug a USB device onto a phone or onto an embedded device, it just works. There's this concept of device classes. We know that when you can plug a keyboard into USB, you can plug a USB stick in, you can plug a sensor in, and they just work. The problem is that if you change an audio device, or you change a Wi-Fi device, or you change a Bluetooth device, it doesn't just work. There's no device class. And we need to change that. And actually, that will help an awful lot of other parts of the ecosystem as well if we can succeed. So one of the things that we in Linaro and the ARM community are doing together with Google is going out to some of the vendors of these key technologies and saying, we want to be able to create a device class. Help us to abstract the fact that you're one vendor, and we need the same function to be able to work from another vendor as well. If we succeed, the world will be a better place from the point of view of writing software for multiple devices. It'll be a lot easier to get devices to market faster for all of us. So finally, I just wanted to show a quick video that Google put together. Can you cue that, please?
Oh, shit.
So we're pretty excited about ARA, and it's a great project, I think, for all of our members. And some of our members are involved, some aren't, but we think ultimately it's going to improve things for everybody. So that's the quick update on Project ARA. Okay. I now want to move on to the last topic, which is something that we've been working on with a number of members for about 6 months now. We first discussed this with the membership in the members meeting in Paris in July last year. And today I'm absolutely delighted to announce the initiative in public for the first time. So what is 96 boards? Well, first I should explain why is it 96 boards. So 96 boards came from the concept that we wanted to create a platform that would enable us to develop software more easily for both 32-bit ARM processors and also for 64-bit ARM processors. So 64 and 32 makes 96. We also have the goal of getting around 100 boards into this program as soon as possible. So it's called 96 boards. And what does it consist of? Well, Linaro is a software company, right? And we're going to stay a software company. We're a software open source engineering company. But what we've done here is two things. We've created a set of open hardware platform specifications. And the second thing is that we're creating a developer community program around this whole initiative. So why are we doing this at all? Well, one of the challenges we've had is that it's still, 3 years on, not easy to develop on ARM64 hardware. Right? I don't know if anybody of you tried to buy any, but it's not a discretionary purchase today. It's not a discretionary purchase for Linaro, unless you pay us a lot more money in membership fees. It's not a discretionary purchase for universities, and it's certainly not for the maker community. It's thousands and thousands of dollars per board. And part of the reason is that actually vendors are not focused on software, they're focused on getting their products to market. But in order to get those products to market, we need to make the software work. We need a better software ecosystem. We need to get access to hardware sooner. So we wanted to find a way of encouraging people to develop software on ARM hardware. And the only way to do that is to get more ARM hardware into the marketplace, into developers' hands. We also wanted to lower the cost and accelerate the availability of maker and embedded products using ARM processors. And we'll talk about that in a moment. So let's start with the specifications. We are announcing two specifications. One is 96 boards Consumer Edition, and the second is the 96 boards Enterprise Edition. And if you think about history, there's an increasing interest in low-cost development boards for the maker community and the software developer community. But if you also think about it, everybody who's producing a board today has to go and create their own ecosystem. They're all doing the same thing. They're all trying to attract the same developers, but they're all doing it in a different way. It's like writing a device driver for the same piece of functionality 10 different ways. They all work, but it's gratuitous fragmentation, right? We want to show and demonstrate innovation in terms of the hardware we're creating and the differentiation we're putting into the hardware, but we want a single ecosystem. We don't want to fragment it, and it's damned expensive to create these ecosystems for each ARM vendor. Each ARM vendor, it doesn't really want to deal with thousands of open source developers individually. It's hard. So what we've done is said, let's create a specification that is cross-SoC. Any vendor can build a board to this specification, and they'll all be compatible. And so the consumer version is low cost, target around $100, say, for a 64-bit board, targeted at mobile embedded and low-end media SoCs. And the goal of this project is for software developers, makers, universities, OEMs, and of course, Linaro engineers. The enterprise edition, and that specification is available today. After this session, you will be able to go and look at it. You can design boards to it. It's an open specification. You don't have to pay anybody anything. You can build a board to it. You can't call it 96 boards unless you work with us and become part of our community. But you can create a board to that spec. There's also an enterprise version of this, which we're targeting at the kind of networking enterprise server devices. That inevitably is going to be more expensive because the SoCs are bigger and more expensive. 48 cores for $100 is still a little bit tricky. And you need a lot more memory typically with these server and networking devices. So these are more targeted at, again, developers and universities, but more at things like build and test farms and SoC evaluation and getting software written for particular SoCs. The enterprise one is running a little bit behind because we started it a bit later. We had a lot of interest in the whole program. And so we actually extended it into the enterprise space, and we're expecting to release that specification in the second quarter of this year. So what are these specifications? Well, basically what they do is they define a minimum set of functionality that you must meet so that we can actually run software on the boards, and we know where all the connectors are. And it defines a standardization of the connectors and the pinouts. What this means is that if I design an add-on module or a product to go on top of one of these boards and connect to the expansion interface, whether it's for the maker community or for an embedded product, it will work on any 96 boards product. So if I'm a display manufacturer, I can create an embedded intelligent display that plugs onto a Linux processor board. And that display, that investment I've made in that display can be used across any of these boards. The minimum functionality for the consumer edition, you've got to have memory, you've got to have either some boot flash or some flash memory, must have a micro SD, must have some USB ports, must have wireless, and must have these expansion connectors with a certain set of functionality. Things like camera interfaces are actually optional, but the capability is there, and then display interface. Must have HDMI. And then the enterprise board basically must be able to be capable of network booting and must have enough to actually enable us to do software development. We're announcing also the community, which consists of a website, the 96 Boards website. Again, that will be live later today, if it's not already. That will include information on how to get these products, documentation, software downloads, and community forums where the community can work together and support these products. And our expectation is that a hardware ecosystem is going to build around this initiative. We're also introducing a new Linaro group. This is going to be a little different from our other groups in that it's more for SoC vendors and ecosystem partners working on this actual program. And there's a considerably lower cost of membership because we're not expecting huge amounts of software engineering resource to come together in Linaro. It's more about each vendor. And therefore, there's no access to Linaro's core and group engineering effort because that requires you to join as a group member in a particular segment. And there's also no assignees. But what the steering committee is going to do is the steering committee is going to kind of own the specification as it evolves. So the companies who are working on the 96 Boards initiative will work together to evolve the specification. And You can attend some sessions this afternoon. There's a hardware session explaining what the hardware consists of, why we've made the decisions we have, and seeking input from the community. That will be this afternoon, and then there's also a software session. So if you're interested in this program and want to find out more, come along to those sessions. So there are a number of companies who are publicly supporting this initiative today. There are other companies involved who I can't talk about today, but as I said at the beginning of the keynote, we do expect this initiative is going to have a big impact on the ARM ecosystem this year. And so I'm really pleased to announce that as well as support from ARM, there is support from vendors in the consumer space, the enterprise space, and in terms of Arrow and Avnet particular, global distributors who are interested in enabling these products to be available globally rather than just in one particular location. So the benefits of this program are we're expecting a lot faster time to market because there's a lot less design effort. We're going to publish schematics for these products. So vendors can quickly create a derivative product for a new SoC. And if you create a derivative product for a new SoC, you've got this whole ecosystem of hardware that you can leverage straight away. So there's a big benefit in doing it. We also, as a result of that single hardware ecosystem, we think that this is going to create a better market for peripheral vendors in the enterprise, in the embedded and enterprise space to be able to build products for this program. It's not just for the processor itself. And we're enabling a software community that we will moderate, that we will have increased resources as the number of boards in the program increases, and that we'll have a single software developer community for all of these boards. And you can see that starting today on the website that we've created for this program. And finally, the important thing about this is it's not about commoditization. The whole purpose of it is that get your SoC into the hands of developers sooner so we can create more software so you can get to market faster. And we're expecting this to be a kind of networking effect. But you don't have to, it's a minimum set of functionality. If you have your own features, your own market segment, and you want to add your own functionality onto the board, go for it. So today, what I'm really pleased to say is that you can publicly, if you go to 96boards.org, you can download the consumer edition specification, and you can also use the website. So this initiative is now public with effect from now. There's press releases going out, and I'm going to ask a few people to come up later and answer any questions that you might have, and I'm sure we're going to have some talks about that this week. But there is one other announcement I want to make on this program, and that is that it's not just a specification that we're hoping members to work with. The first board is actually being announced today by a company that's built a number of open source consumer boards called CircuitCo, and they have announced the high key product, and I happen to have one here. This is an early access board. They're just starting production. The board is very small, very slim. It's a credit card size, and this board actually has 8 64-bit ARM cores on a single SoC. It's an octal core SoC. These boards have been designed not only for us, for software developers, but also for product makers. It's incredibly slim. You can put this into a robot or a UAV or an embedded product, and it really isn't going to take up much space. So this is the first 96 boards compliant board. It uses Linaro member HiSilicon's 8-core 64-bit A53 SoC. And it's available today for pre-order at $129 from distribution. So think about that for a minute. We don't have to pay $6,000 to get a piece of ARM hardware anymore. $129, and anybody can get one. And we think this is going to have a significant impact in getting ARM hardware, 64-bit hardware, into the hands of software developers globally. Universities, embedded product developers, and software developers. So we're really excited about this board. That's what it looks like. Think about this. It has over 10,000 Drystone MIPS total performance, right? We can actually run Java on it. It also has a Mali MP4 GPU, has a gigabyte of RAM, 4 gigabytes of flash storage, and I think some of the Linaro groups are going to be starting to use it as an absolutely standard piece of equipment to demonstrate and to do things like work on Android and optimization. So it's no good just showing you a piece of hardware, right? You want to see it doing something. So I'd like to invite the team who've worked very hard, or some of the team who've worked very hard. This has been an effort across Linaro to come and demonstrate and show you some of this technology. So let me just get some preparations underway here. And would you like to come up, guys? So Fathy and Barrow are going to do an initial demonstration for you here. This is what they're looking at. So they have here a high keyboard in the middle. The one on the left is for a demonstration that Vishal is going to do in a minute. And they have that board connected to a USB hub with mouse, keyboard, and Ethernet. And then they have an HDMI connector that's connecting to this monitor. And if I switch over here, we have a Debian login. Take it away, guys. You got a microphone there, so you can say what you're doing.
Yeah. So we just logged in on the Debian ARM64 GC. I'm just going to show you a few things on the command line. I'm not sure you can see it. So we see the AR64 kernel. As George mentioned, we can see that we have 8-core online. Network is working. I can ping Google, probably. Yeah. Not yet any demo effect. Yay! And I'm going to hand over follow-up to Beryl.
Yeah. Vishal actually did such a great job at doing most of the Android bring up that I could take a little detour last night and actually work on regular Linux bring up. So Vishal will be demonstrating Android in a bit. And in the meantime, we really want to show the power of this board by showing you some technology that you might only have imagined from seeing science fiction movies or the likes. So imagine what you can do with a high keyboard.
So what you're seeing here is a preview of Debian 8.0 Jessie release running on the 8-core high keyboard. We've only had the board for a few weeks, so we're excited with where we are. And I'm going to talk a little bit about availability of what you're seeing in a moment, so you can play all your Commodore games. And we're using a 10,000 Drystone MIP product to do this. Well done, guys. Right, we're now going to hand over to Vishal, who's going to demonstrate Android. And what you've just seen was it isn't quite TIP, but it's a mainline kernel. It's a Linux 3.18 kernel. We will be making the source code available to you today. And we're pretty excited by this whole program. One of the things that I'm very pleased the mobile group's doing is improving Android boot speed. But here we go.
Yeah, this is Android 5.0 running. Sadly, I'll not demonstrate Angry Birds this time. It has Wi-Fi connected, and we have our Connect stuff shown up here. One of the goals is to get the graphics accelerators integrated this week and make it smoother. Yep. That is it.
Thanks very much.
Yeah.
Thanks. Thanks very much, guys. So this is now over to you, right? We have Android, we have Debian, and I'm sure there's going to be a lot more on the way. So early access builds are available tomorrow. Preliminary documentation and schematics are on the website. There is a buildable 3.18 kernel source code tree, which will be hosted on GitHub. And that is for the ARMv8 pre-release Debian 8 Jessie build that you've just seen demonstrated today. We've got a lot of goals for this week. We hope you're going to help us. We're planning to actually, by the end of the week, our goal is to release bootloader source for this board, including ARM-trusted firmware and UEFI. And we also want to enable you to get access to the Android Lollipop build from AOSP that you just saw demonstrated. A key goal for this week is to get the Mali graphics acceleration going. Not many people have done this for 64-bit chips yet. And we think there's going to be a lot more work done on these boards just this week, and then in the coming weeks as more boards arrive. So we're really excited by this. Also, tomorrow, we're going to set up 15 boards in this room next door for the rest of the week that you can use to play on, hack on, and experiment on. Please do not take them away. Please let people play with them, right? Let people play with them. A number of the early access boards that I've shown you are going to be available. Did mine walk away already? Are going to be, somebody's walked away with it already. are going to be available to Connect attendees. So what we want you to do is, if you want one, tell us what you want to do with it. And assuming we have enough, and we hope we will have, we'll arrange for you to take one home with you at the end of the week. So go to this website, 96boards.org. I want one. Just give us the reason you want one, and we'll provide boards for you at the end of the week. If you can't get one, then you can actually order them online today. So we're pretty excited by that. So I just want to conclude this by saying I actually think this program is going to have a big impact on the whole ARM software community. We're finally going to be able to get ARM 64-bit hardware and low-cost hardware for all of the projects that we do within Linaro and that you do in the membership. And we're going to be able to get those out into people's hands across the industry at a far more affordable way than's been possible before. And if you look at what's happening in this industry with things like Raspberry Pi at the low end, where they're doing amazing work in getting $35 boards out to students and high school kids, we think this program is going to have a deep impact on the industry in terms of higher end software development, universities, and embedded products, and the maker community. So we're really excited by this. So what I'd now like to do is invite a few of our members to